All right, so you may have listened to the news one night and heard the anchorman report that there's a margin of error on some poll of plus or minus 3%. What does that mean? Why is it plus or minus 3%? What is the margin of error? I am going to walk through this with you in Excel. I choose Excel because we really get to see this data take shape step by step right before our eyes. We're going to visualize our results, and we're really going to understand with real life data what this margin of error is and what it tells us. So if you have some familiarity with inferential statistics, I think this will help. You'll know that in inferential statistics, what we do is take a sample of data and make claims about a population with it. So the margin of error is telling us what is the range within which we would expect to find the population mean with the claim that we've made. So the larger the margin of error, the bigger range around which we would expect to really find that population mean. Conversely, the smaller the margin of error, the more likely we are. There's a formula here over on the right. The margin of error is a product of the critical value, generally 1.96 for a two-tail test at the 95% confidence interval. We're going to multiply that by the standard error. That is the standard deviation divided by the square root of our sample size. And this chart over here on the left just kind of shows you visually what the relationship is between our sample size and our margin of error. The bigger our sample size, the more data that we have, that's more information, right? So that means that our margin of error should be lower. Okay, so I've got a starter worksheet here. We'll go ahead and work through this. You've got a demo file as well that will walk you through this, so you can take a look at that if you'd like to as well. But I'm going to go ahead and set this up. So our sample mean, this is essentially a running average. So the way I'm going to do this is start our range off at B7, then we're going to end that at B8, but I'm not going to lock B8. I'm only going to lock B7, and you'll see why in a minute here. When I fill this in, you'll see that we've got a range always starting at B7, but always ending at our respective row reference. So for example, I'm going to fill out this range here. If I go to my status bar here at the bottom, you'll see that our average is indicated as 54,785, 786. That's what we have here. So this is just a rolling, a sample mean. Cumulative, the more sample size that we add, our mean adjusts accordingly. Okay, so we're going to do the same thing with a standard deviation. We want essentially a running standard deviation. So I'm going to use the standard deviation. Again, it's a sample that we have. We are working with the sample. We want to know the population. So I'm going to do the same thing here. We will start with B7 always. I'm going to lock that down and then end with whatever row we happen to be at here. So let's drag that down here. And I've got these formulas up here. Let's go ahead and make that a little bigger so that you can see exactly what formula I'm using to fill these things out. Okay, so we'll move to the standard error next. And again, we've got the formula over there on the right, which is the standard deviation divided by the square root of the sample size. So I can take that, D8, divide that by the square root of column A. So we've got our standard error. You may notice that I've got this first row kind of grayed out, and the reason I'm not calculating those is if we've only got one sample size, then it doesn't really mean anything to take something like a standard deviation. A standard deviation kind of implies that you've got more than one data point. Otherwise, you're not going to have variance if you've only got one data point. So we just leave that blank. Okay, so now let's look at the critical value. Now, since we're dealing with very, very small sample sizes, especially at the beginning, we want to adjust our critical value. Usually, again, it's 1.96. However, we're dealing with such small sample sizes that we want to be more conservative. So I've got a lookup table that we'll hit up in a minute here. I'm going to go to our critical value worksheet, and let's just fill that in. Okay, so there's our critical values. I want to do an approximate lookup here. What this is going to do is, again, you'll see that some of these values do not have an exact match, right? So if we wanted to look up the critical value for a sample size of 61, We don't have that exactly, so we need to do an approximate lookup there. So I'll do that, and again, you can see that this is much higher than 1.96 at the beginning, right? Because we're dealing with a sample size of 2, so we want to be more conservative. But if I go down to the bottom here, then we get to 1.96, which is usually what is used. Okay, so we're getting close here. I'm going to find the margin of error, and again, we've got our formula right up there at the top. So I'm going to multiply our critical value by our standard error, and let's drag that down. And now, last but not least, I want to find the margin of error as a plus or minus percentage of the mean. So the way I'm going to do this is we've got our total margin of error here. So let's just pick one of these rows at random. Okay, I've got a sample of 23. Our sample mean is 52.5. Our margin of error is 79.3. So what we're saying is that we've got a mean, right, of that, $53,000. We've got $8,000 or so spread across that mean. We expect to find our population somewhere in that range. So we basically want to take this value divided by 2, right, because we're going to say plus or minus. In this case, it would be, plus or minus about $4,000, because again, we could go either way. The 79.30 is inclusive of both sides of the direction. Okay, so in that case, what we'll do, I'm going to divide our margin of error. Again, this is the sample mean. I'm just going to take this by 2 to account for the fact that we want a plus or minus, right? We want a whole inclusive range. So plus or minus 3% is a 6%, range divided by 2, plus or minus 3%. Okay, so let's do that. So we're starting with a margin of error of 9%. That's pretty high, but I'm going to drag this down, and eventually we get to a margin of error of much lower than pollsters get. We've got a margin of error of plus or minus 1.6%. So let's just take a look at the chart over here for a minute. What we're seeing is this is one of those things in statistics. You want to know, what sample size do I need to conduct inferential statistics? Well, 30 is kind of the base cutoff oftentimes. So if we look over here at 30 on the chart, we definitely see that the graph kind of tapers off at 30 in terms of the margin of error. It really reduces. It's pretty wild at the beginning, but once we get to 30, it starts to get somewhat tame. 60 is another cutoff that you often hear, that you want a sample size of 60. So we can see that it tapers off at 60, and then 100 is a very conservative sample size minimum. We can see there that the margin of error actually goes up a little bit from 60 to 100. So again, we're still kind of dealing with some volatility, but it's, pretty minor. It still hovers around that 4% mark. And then once we get to 100, it's pretty smooth sailing. The more and more data that we add, the lower our margin of error becomes. So this is what, when you hear that idea of a sampling of a margin of error of, plus or minus whatever percent, think of this. It's related to the sample size. It's related to our standard error, which is in part related to our sample size. So I hope that this helped. Again, I'll have the file for you to work with. We've got the start worksheet that you can, run through this on your own if you want it, and a demo guide, a printable PDF that you could work on this on your own. So I hope that this helped again. If it did, please let me know. And I've got a resource library of all sorts of teaching guides and this sort of thing. So if you want to learn statistics or data analytics in general, if you want to teach it, I think it could be useful for you. So I'll link to getting set up with that resource library as well. Thank you again for tuning in. And next time you watch the news, I hope you are a little more equipped to understand what that margin of error actually is telling you. Thank you. Bye.